let us discuss the empirical evidence on the shape of cost curves. The importance of cost curves in production is that it determines production decisions of producers and points to the existence of many empirical studies which prove about the shape of cost curves. The whole theory of cost is based on basic and fundamental concepts of the cost function. The cost functions are derived from the technological relationship implied by the production function. Therefore, the basic argument that we are making over here is that the production function and the cost function are the dual of each other. In fact, theory of cost is a restatement of the theory of production in monetary terms. The shape of cost curves depends upon the time period, the type of the industry, the economies of scale, the diseconomies of scale, and so on. The shape of the long-term cost curves has been different under traditional cost theory and the modern cost theory. Since the process of production involves planning and constant vigilance, the producer aims at efficiency and the maximization of profits. The modern theory takes cognizance of the managerial and technological economies to explain constant returns to scale, and thus the L-shaped long run average cost curve arises in the long run.
After studying this module, you shall be able to know the empirical evidences on the shape of cost curves, identify different types of empirical cost studies, evaluate different types of empirical methods of studies, analyze how the shape of cost curves have been empirically tested by different studies. A number of empirical cost studies on the shape of cost curves have been done. They are statistical cost studies, engineering cost studies, questionnaires-based studies, statistical studies of production function, studies based on survival technique.
Firstly, we learn about the statistical cost studies. Statistical cost studies are based on regression analysis and time series data, also sometimes on cross-sectional data. The procedure used in statistical cost studies begins once the data is collected by the researcher. Time series data includes observations on different magnitudes, that is different variables such as output, cost, price, etc. And this is collected from the firm over a period of time. Cross-sectional data gives information on variables such as inputs, costs, outputs, and so on of the relevant magnitudes drawn from a group of firms at a given point of time. In principle, what we can say is that one can estimate the short run and long run cost functions either from time series data or from cross sectional data. We may estimate a short run cost function either from time series data of a single firm over a period of time during which the firm has given rise to new plants and the plant capacity has been increasing and has been utilized at a different level. For example, it could be due to differences in the demand fluctuations, or through a cross section of samples which have the same plant capacity, each of them operating at a different level of output for any reason. It could be consumer preferences, market sharing agreements, and so on. Due to the difficulties in obtaining cross-sectional sample of firms fulfilling these above conditions, short-run cost functions are typically estimated from time series data of a cost of a single firm whose plant has remained the same during the period under study. We may estimate the long run cost function either from time series sample including cost output data of a single firm whose scale of operation has been expanding with the same state of technology, or a cross section sample of firms with different plant sizes being operated optimally as its minimum cost level.
Let us now understand the relationship and shapes of different cost curves under modern theory of cost. The following proportions of the SAVC curve show the reduction in costs due to better utilization of the fixed factors and the consequent rise in productivity of the variable factors. The rising portion of the SAVC curve depicts the rise in costs on account of diminishing returns from the variable factor and also overutilization of the fixed factors. The SAVC curve has a flat stretch over a range of output, wherein the SAVC is equal to the short-run marginal cost, both being constant per unit of output. The short-run average cost curve continues to fall even over the range of output x1 and x2, corresponding to the flat stretch of the SAVC curve, wherein SAVC is assumed to be constant. As average cost consists of average fixed cost and average variable cost, and average fixed cost continues to fall as the level of output increases. Even after the planned reserve capacity is exhausted, the short-run average cost curve continues to decline despite rise in SAVC because AFC continues to fall throughout. Eventually, the rise in short-run average cost becomes greater than the fall in average fixed cost, and the short-run average cost starts to rise. The SAC curve is intersected at its lowest point by the short-run marginal cost curve, as in case of the traditional theory of costs. Beyond OX3 level of output, the SAVC curve asymptotically approaches the short-run average cost SAC, since the gap between the two curves gradually diminishes on account of falling AFC, but the two can never coincide because AFC cannot be zero. Engineering cost studies. This method is based on the technical relationship between inputs and outputs. The cost function includes the cost of the optimal method of producing various levels of output. The L. Cook and Booth study of the costs of operation of crude oil trunk lines employs the engineering method.
From the available engineering information, the researchers decide about what the optimal input combination for producing any given level of output is. These technical optimal input combinations are multiplied by the price of the inputs, that are factors of production, to give the cost of the corresponding level of output. The cost function includes the cost of optimal, that is the least cost methods for producing various levels of output.
Let us study about the first stage of the engineering cost studies method. The first stage involves the estimation of the production function, where output was measured as barrels of crude oil per day, and the main inputs in a pipeline system are pipe diameter, horsepower of pumps, number of pumping stations. Second stage of the engineering method is the estimation of the cost curves from the production function. Out of the various combinations of inputs to produce a given level of output, the least expensive combinations are chosen. The long-run cost curve is formed by the least cost combinations of inputs for the production of each level of output. The Cook and Booth study concluded that the long-run costs fall continuously over the range of output covered by his study. However, it should be noted that engineering cost studies are mainly concerned with the production costs and pay less attention to other costs. The questionnaire-based studies A questionnaire consists of a set of well formulated questions to probe and obtain responses from respondents. Studies based on questionnaires where most of the firms reported that their costs would not increase in the long run and also would remain constant over some period of time. Now we shall study about the statistical studies of production function. According to the modern approach to the theory of costs, the long-run average costs essentially consists of production and managerial costs, and the average production costs continue to fall considerably even at large scales. Now, modern theory of costs proponents point out that the technical and production economies of large-sized plants make the rising managerial costs seem insignificant, and production costs tend to fall continuously with increases in output in the long run. These costs fall steeply in the beginning and then gradually as the scale of production expands. This behavior of the production costs is explained by the technical economies of large-scale production. Most statistical studies of production function reveal constant returns to scale when costs are constant over a certain range of output. The survivor technique, which is developed by George Stigler and is based on Charles Darwin's survival of the fittest doctrine. George Stigler studied the steel industry of USA and deduced that small and large firms have high costs and are inefficient, but the medium-sized industry constitutes the optimum firms. Further, the basic idea of this technique is that competition between different sizes of firms will lead to survival of the more efficient ones.
The method implies that firms with the lowest cost will survive through time. The basic postulate of the survivor technique is that the competition of different sizes of firms sifts out the more efficient enterprises. Therefore, by examining the development of the size of the firm in an industry at different periods of time, one can infer what is the shape of the cost in that industry. Presumably, the survivor technique traces the long run cost curve since it examines the development over time of firms operating at different scales of output. In applying the survivor technique, firms or plants in an industry are classified into groups by size, and the share of each group in the market output is calculated over time. If the share of a given group or a class falls, the conclusion is that the size is relatively inefficient, that is, that the high cost, that is, decreasing returns, are being experienced. The criterion for the classification of firms into groups is usually the number of employees or the capacity of the firm as a percentage of the total output of industry.
There are certain assumptions on which the validity of the survivor technique theory would depend. These are: 1. The firms have same objectives. 2. Firms operate in similar circumstances. 3. Prices of factors and state of technology is constant. 4. The firms are operating in a competitive market structure.
Even if conducted with the greatest care and in conditions where the mentioned assumptions are fulfilled, the survivor technique indicates that the broad shape of the long run cost curve, but it does not show the actual magnitude or economies or the diseconomies of scale. Another shortcoming of the survivor technique is that it cannot explain the cases where the size distribution of firms remains constant over time. If the share of various plant sizes does not change over time, this does not necessarily imply that all scales of plants are equally efficient. The size distribution of firms does not depend only on costs. The size distribution of firms depends also on the changing technology, the factor prices, entry barriers, collusive practices, objectives of the firm, and the other factors such as cost should also be taken into consideration while analyzing the size distribution of firms over time. According to the traditional theory, the long run average cost curve is U-shaped, like the short run average cost curve. But some economists have found empirical studies whereby the long run average cost curve is L-shaped rather than being U-shaped. The long run average cost curve first falls rapidly in the beginning. This is due to increasing returns to scale, but after a point it becomes fully flat or may slope downwards slowly. Such an L-shaped cost curve, which is shown in the figure below, it clearly shows that the shape of the long run average cost curve is no longer U-shaped but tapers down and becomes parallel to the x-axis. According to most of the empirical studies, there is an increasing returns to scale in the lower level of production, but when output increases, the economies of scale decline and it leads to constant returns to scale when the output occurs at a higher level of production. This implies that the output, as the output increases, the long run average cost curve slopes downwards initially and finally it becomes horizontal. The operation of the decreasing returns to output or the average cost curve rising after a point are rarely found, in fact, in the practical world. The decline in cost with size is almost universal, but the increase or the upward turn of the U shape of the long run average cost curve is rarely found in practice. The rapid increase in cost along with size is practically unknown and it is very rare. Some economists have remarked that most of the cost functions obey what is called the L-shaped cost curve. Johnston has also derived the same conclusion from his study. From his study, the cost estimate of the long run average cost curve was derived from the case of electricity production in Great Britain, and he found that the average cost declined in the beginning and then leveled off. So, the reasons for the long run average cost curve becoming L-shaped are the following. First of all, technical progress. One reason why modern empirical studies do not find a U-shaped long run average cost curve is that whereas economic theory assumes that the technology remains unchanged or there is no technological progress, in the real world technological progress does take place over time. As a result of technological progress, in the real world, the long run average cost curve would be shifting downwards over time. The empirical investigations into this phenomenon are based on time series data and would find the case that the rising average cost curve does not actually exist due to the phenomenon of constantly increasing technological progress. Thus, while the case of unchanged technology is assumed in the traditional cost theory, and the long run average cost curve looks U-shaped in empirical studies conducted on the basis of data belonging to different points of time. In between, technological progress has taken place, and therefore we find that the long run average cost curve is L-shaped. In the case of cross-sectional studies where both small and large firms use different technologies, and there we find that the average cost curve is actually falling. In the view of technological improvement, we cannot therefore find an average cost curve which is rising in terms of empirical cost functions and empirical studies in relation to cost functions. Suppose initially the firm is producing OQ1 output at OK1 by operating on LAC1. Now, if the demand for the firm's products increase to OQ2, then in the context of unchanged technology, the firm will expand production along LAC1 and will produce OQ2 at the cost OH. Now, if the technological progress has taken place and in accordance with the new technology, the firm installs a new plant whose long run average cost is LAC2, the firm will produce on the new curve LAC2. The output would then be OQ2 at a cost per unit which is less than both OK1 and OH. Likewise, when the firm at some later date has expanded output to OQ3 in response to technological progress, the demand increases for its product and technology may have advanced in the meantime, so that the firm produces OQ3 at OK3 cost per unit which is less than OK2. By joining the minimum point of the long run average cost curves, we get an LAC which is gently sloping downwards due to technological improvement that has taken place over time, whereas with unchanged technology, the long run average cost curve LAC1, LAC2 and LAC3, each with a different but unchanged technology, is U-shaped. The empirical cost functions which are conducted and measured through empirical studies made by economists at different points of time would estimate the OK1, OK2 and OK3 units of cost at outputs of OQ1, OQ2 and OQ3 respectively, and would therefore suggest that the long run average cost curve was like the thick LAC which is depicted. We therefore conclude that while with a given and unchanged technology, long run average cost curves are U-shaped, and empirical evidence would find that the long run average cost curve is L-shaped, and we could attribute this phenomenon to technological progress which has taken place over time. The fact that technology changes does not in itself appear as a contradiction. Our convention or our belief is that it is only because it is harder to manage a larger firm than a small one in the long run, that the long run average cost curve becomes U-shaped in a with a given state of technology. Now, let us understand the phenomenon of learning by doing. The long run average cost curve completely slopes downwards due to learning by doing. Since the efficient firms increase due to continuing the work, they are able to reduce the cost. As the output increases, there is not only an increase in the knowledge of many things, there is also an improvement in the management of plants. Due to this, the LAC becomes L shaped. Another factor is management techniques. According to the modern theory, appropriate administrative structures are available to operate the plant of each size. There exists appropriate management techniques at different levels of management. The management techniques are available both for large and small size plants. The cost of different management first fall up to a certain plant size, and the managerial cost slowly increases after a very large level of output.
Let us now summarize what we have learned in this module. There are several empirical methods of testing the shape of the cost curves. The empirical evidence from most statistical studies is that in the short run the AVC is constant over a considerable range of output, and in the long run the AC is generally L-shaped. The Cook and Booth study concluded that the long run costs fall continuously over the range of output covered by his engineering cost studies. Most statistical studies of production function reveal constant returns to scale when costs are constant over certain range of output. Studies based on questionnaires where most of the firms reported that their costs would not increase in the long run and also would remain constant over some period of time. The basic idea of the Stigler technique is that competition between different sizes of firms will lead to survival of the more efficient ones.